Okay, finding the inverse of a function. So here are the basic steps. You're going to rewrite this f of x notation. We're going to rewrite that as y is equal to. Then you're going to swap the x's and the y's. You're then going to re-isolate y by itself, solve for y. And then when you get y by itself, you're going to replace the notation, and that because you'll have found the inverse. So let's get started. So here is our original function, and I'm just going to rewrite that as y is equal. Now I'm going to swap the x and the y, which is what I did right here. Whoop. That's all I did. And now we need to get that y by itself. So we're going to subtract 4/3 to both sides, which leaves us with those two zero out. All right. Now we need to get the y by itself, and 4/3 is attached by multiplication. Typically we think of dividing, but remember, division is the same as multiplying by the reciprocal, which is I think what I did right here. Yep. Notice I put this stuff, I put parentheses around it before I multiply, because you have to multiply everything by 3/4. And then that leaves us with y, and the only thing I'm going to do left here is do the distributive. So we end up having 3/4 times x is 3/4 x. Here's a subtract sign, so I put a subtract sign. Well, 3/4 times its reciprocal 4/3, that cancels to 1. And then y can be rewritten as f with the raised -1 of x. The other way that you could do it is sometimes professors will want the denominators to be the same. So all I did here, you could multiply top and bottom by 3, and that would give you these two things mean the exact same. One just has a shared denominator and one does not. All right, so now we have the steps right here. We're going to rewrite g of x as y is equal. We're going to swap out the x's and the y's. Notice that is now a y. The x is now here. And I'm going to systematically start getting the y by itself. So we're going to subtract 2 to both sides. And that leaves all this by itself. And over here, that leaves x subtract 2. What's the undoing of something to the 5th root? Putting something to the 5th power. When you do it to the right, you have to do it to the left. I think I already had that. Yep. And then look what happens. When you have something to the 5th root and you take it to the 5th power, those things cancel, leaving y plus 1. And now all we have to do is subtract 1 on both sides. And then we will have the inverse, and we can rewrite y, as these cancel, we can rewrite y as in the inverse notation. Okay, so let's do, we're going to do this one, then we're going to graph one. So again, y is equal, we're going to swap the x's and the y's, and then before we can get to all of this, we're going to have to subtract a 2 to both sides. We did that. And that leaves negative. Now here's the tricky part. We could take the time and multiply both sides by this denominator, and then you'd have a binomial. Or remember what I have told you all before. There's an invisible 1 right there. When you have something, you have a fraction on both sides of the equal sign, you could just flip both sides. So now look at what we have. We have 1 over x subtract 2. And over here, the negative sign we still keep, but we have y plus 1 over 3. Well, now our job is to get the y by itself. How do we cancel a dividing 3? We multiply by 3. Well, 3 times 1 is 1, so over on the left, and notice I multiplied it by negative 3. Oops, I forgot to do that, because there's also a negative sign right here. So if I multiply this by negative 3, it cancels both the 3 in the denominator, and what's a negative times a negative? A positive. So we're going to multiply this by negative 3, and there we have it just like that. And then what I have on the right side, since those canceled, I now have y plus 1. I'm going to subtract 1 on both sides. I'm probably going to first do the distributive. No, I just left it like that because I think this is how CUDA software had it, and I think I went ahead and left it that way. So you can sometimes, you don't have to simplify fully. If we had, this just would have been a negative 3 right there over all of that. And then we could have multiplied top and bottom, but it's okay if we leave it just like that. And then we're going to rewrite it. Boom. Now, there's something that you need to know about graphing. So let me think of something. So a cube root function, I did not draw that very well. Looks something like this. I mean a cube function. So x cubed looks like this. Well, x squared x cubed and it's going to be really hard to actually see what I just did there. But if we put this invisible line right here, these two things would look like mirror reflections. Well, that's how you tell if functions are inverses of each other. If you graph them, and when you have an invisible kind of line that goes at a 45-degree angle right there, if this side and this side end up looking like mirror reflections, then yes, you have things that are inverses of each other. So here we have this function, f of x is equal to negative 3 plus 1/4 x. If we find the inverse, I'm going to write that. I'm going to swap out the x's and the y's. Whoops. And now I'm going to get the y by itself. So I'm going to add 3 to both sides. Those zero out. And now we have 1 over 4y. Well, it's attached by multiplication, but I don't want to divide a fraction, so I'm going to multiply by the reciprocal. I'm going to do the distributive. So that becomes 4x plus 12 is equal, and then here's your inverse. If we were to graph both of these, and funny thing is, I did, let's see. There we go, right there. This is what that would look like. Notice this first graph right here. We'd be down here at negative 3, which is right here. And then this says plus 1/4 x, so we'd go up 1 over 4, and then down 1, back 4, and then you can hardly see it, but it is this line right here. And then when we graph the other one, well, the inverse is 4x plus 12. Well, 12 is clear up here someplace. Change that to blue. I don't know where it is. And because we can't go up 4 over 1, I'm going to go down 4, back 1, which would put us at 8. And then we're going to go down 4, back 1 again. And then I'm going to go down 4, back 1 again. And I'm going to go down 4, back 1 again. And then if you will notice, look at the graph of these. They are inverses of each other. Notice, here's -3 and -3. Look at these things. So graphically, you can see that these are inverses of each other. And we know that they're inverses when there's that diagonal line at a 45-degree angle on the coordinate graph. When you draw that angle and then when you look at both sides, it looks like a mirror reflection. You've got an inverse. All right, that's it for this one.